Welcome to Theory of Computation class. Today we should know about automata fundamentals, which comes under first unit of Theory of Computation. There are two major topics that is available in Unit 1. The first part of Unit 1 is a basic mathematical notation and few techniques which are implemented those mathematical notations. And the second part of Unit 1 is finite state systems. Now we should know about the basic concepts behind theory of computation. Theory of computation is one of the fields in domain of computer science used for efficient computation and different computational process models. So this TOC concentrates on problem solving by using different models of computation. We are all aware of that few problems are easy, few problems are hard. So depending upon the solution for those problems, it will be categorized as solvable problems and unsolvable problems. So the domain of computation is divided into automata theory, computational theory, and complexity theory. So the foundation of computer science is divided into two parts, that is called as theoretical part and non-theoretical part. So the theoretical part comes under theory of computation and non-theoretical part can be implemented with the help of theory of programming. So basic idea behind these concepts, we are all aware that theory of computation describe basic ideas and the model of computing those ideas in it. And also theory of computation is used to understand the nature of computer, and theory of programming is used to implement those computations. We are all aware that computation involves taking some inputs, performing few required operations based upon the input, and it will produce an output according to the particular situation. So it describes the basic ideas and models of computation. So it is also known as theoretical foundations of computer science. So an automation is a study of abstract computing devices or machines. So this theory of computation is used for designing and checking the behavior of digital circuits, lexical analysis, and scanning the large bodies of text in a particular way. Here a few are listed out as the applications of theory of computation, which are all known as language design. Language design means either it may design a programming language, and for the programming language we are in need of a translator for running those program. So this theory of computation is also involved in designing of a computer. It will also be used in robotics, artificial intelligence, and knowledge engineering. Now we should aware of the basic concepts of automata theory, which comes under some mathematical notations in it. Using the basic mathematical notations, some operations can be performed in an automata. So these are all the five concepts which are all behind the automata theory. First one is an alphabet. Second concept is a string. Third one is a language. And fourth one is grammars. And the last one is graphs and trees. First, the first topic is alphabet. Alphabet means the definition of alphabet is a set of finite and non-empty symbols that will be denoted with a symbol called sigma. So this is a symbol sigma which is basically defined for an alphabet. So an alphabet may be a single letter symbol or two letter symbol or three letter symbol. So we describe alphabet as a finite set of symbols. For example, sigma is equal to AB, which is described within a set. So it is described as an alphabet of two symbols A and B. Here, this is the example for the second one. So, sigma is an alphabet, set of alphabet, which contains three symbols in it. That means 0, 1 and 2. So, it will be described as alphabet. Using the alphabet, we may be able to form a collection of words. Those collection of words are called a string. So, this is the definition of a string. A string is a word which may be formed by the alphabet set. So we are all know that alphabet set is a finite sequence in it. So for example, alphabet here an example is given for an alphabet set. Sigma is equal to AB, and what all the way of forming a string means we can able to form a string with a single letter word or two letter word or three letter word based upon this alphabet symbol. So if you want to frame a single letter word means only two possible strings are possible. One is A and the second one is B. These are all single letter string. Two letter strings means AA, AB, BA, BB. If you want to frame a three letters string means there are two alphabet symbols are available. So the number is described as 2. Length of the string is 3. So 2 power 3 means there may be the possibility of 8 strings are possible. And using those strings we can able to implement few operations in it. So these are all the list of operations which can be performed on string. First one is length of a string. We can able to find the number of letters in a particular string, and we may able to find whether the string is empty or not. It is denoted as empty or null string, and we can able to concatenate or append two more strings, that is called as concatenation. One string can also be reversed by the operation is called reverse. And power of alphabet means what are the maximum number of possible way of writing those strings with any length. Substring means finding the possible intermediate strings within a particular string. And the last operation is palindrome. Now we'll go through each operations with an example. The first operation on string is length. So here W is represent a word or a string. Mod W is a symbol which is represented for length. So mod W is described as the number of letters or alphabets which are all available in a particular word. Here a few strings are listed out here with the calculations. So for example, if you take a word or a string W is equal to AB. So mod W means the length of the string. So here W contains 4 letters. So A, B, A, B. Even A, B are the alphabet values, alphabet symbols. Using that alphabet, we are framing 4 letter string. So number of letters are 4. If you take W is equal to 0, 1, 2, the number of letters are mod W, that is 3. So if you take W equal to 000, we may able to find the value of mod W for this one. This is 3. And if there is no string is available that is described as empty or null string, which is framed as W equal to epsilon. So W equal to epsilon means there is no letters in a particular string. So mod W equal to 0. The other operations will be discussed in next class. Thank you.